Hi, welcome back to the final exam review examples part C. This time we're going to look at the B versions of our questions. So 1B, June's yard is rectangular and has dimensions of 24 feet by 52 feet. Winnie's yard is similar to June's yard. If the area of Winnie's yard is 7,500 square feet, what are the dimensions of her yard? So it's going to be similar to this problem, just a little bit more involved, and it also doesn't give me a picture. So the first thing I'm going to do is I'm going to start by trying to sketch myself a picture. But before I do that, I don't want my questions to kind of run into each other. And I feel like this might have quite a bit. So I'm going to draw myself a little line here to separate 1A from 1B. All right, starting with June's yard is rectangular. And it has dimensions of 24 feet by 52 feet. So I can find the area of that because base times height, 52 times 24, is 1248. This is June's yard. Winnie's yard is similar, but it has an area of 7,500 square feet, so it has a much bigger area. So Winnie's yard is similar but bigger. We have an area of 7,500. What are the dimensions? So I want to find the base length and the height length of Winnie's rectangular yard. Okay, so now you can see I look much more similar to part 1 now that I've drawn a picture. I'm going to make a SPA table. And what do I have 2 of? I have 2 areas. I'm going to put June always in the numerator and Winnie always in the denominator, and that's just something you get to decide. Just make sure you stay consistent. So I'm going to put June's area in the denominator, or in the numerator, and Winnie's area in the denominator. And let's reduce that fraction. 1248 divided by 7,500. Make it a reduced fraction. 104 to 625. Now I know my area is my scale factor squared, so I need to unsquare it to get down to my scale factor. The square root of 104 is a decimal, which means I'm going to leave it as the square root of 104 so that I'm not rounding all the time. Okay? The square root of 625 is 25, so I can change that into 25. So the scale factor is the square root of 104 over 25. The ratio of the perimeters is the square root of 104 to 25. Okay? So if I'm trying to find the side lengths, I can use S for scale factor or S for side to do my comparison. So I know the square root of 104 to 25 is what my sides will reduce to. So if I want to find the base length of Winnie's yard, I'm going to compare that to the base length of June's yard, where June's going to go on top because that's where my up arrow is. And Winnie's going to go on the bottom because that's where my down arrow is. And then I'm going to cross multiply. B times the square root of 104 equals 52 times 25. 1,300. Then to get rid of that square root of 104, I'm just going to divide both sides by the square root of 104 because it's just being multiplied to that B. At this point, I'm going to have to go to my calculator and I will have to be okay with a decimal. B equals 1,300 divided by the square root of 104. So the base length of Winnie's yard is 127.475. And these are feet. Okay, let's look at the height of her yard. Okay, it's still going to reduce to the same scale factor. So the square root of 104 over 25 is going to reduce to the heights compared together. June's height is going to go on top, and Winnie's height is going to go on the bottom. So basically, I'm doing exactly what I did on number 1. I'm just doing it twice because I want to find both sides of that rectangle, not just one. Cross multiply the height times the square root of 104 equals 25 times 24, 600, divide by the square root of 104. And my height equals 600 divided by the square root of 104, which is 58.835 feet for the height for Winnie's yard. Now look what happens if I take this 127, I'm going to go grab it out of the calculator, and if I multiply that, that's my base. If I multiply that to the height, my 58.83, so on and so on, when I multiply that base times that height, I get pretty darn close to my 7,500. The reason it's a little different is because even the calculator eventually kind of rounds a little bit, right? So there's going to be a little bit of rounding error, but if you round this, it's going to give you your 7,500 for the area of Winnie's yard. Okay, so we can feel confident that we got the correct answers for each of those. All right, let's look at 2B. The radius of a sphere is 8 inches. Find the surface area to the nearest hundredth. So surface area of a sphere. So same as 2A. So I'm going to use the same formula. S equals 4 pi r squared. S equals 4 pi. My radius, they gave me the radius, is 8 squared. So S equals 4 times 8 squared, 256 pi. It does say to round this to the nearest hundredth, so that's 2 places after the decimal. So I'm going to multiply my pi in, and my surface area is 804.25. My units are inches squared. Number 2. Let's look at number 3. Find the lateral area of the regular pyramid. So I'm going to use the same formula as last time because in both of them we were finding lateral areas of regular pyramids. So my lateral area equals 1/2 PL. So my lateral area equals 1/2 my base. In this regular pyramid, it's regular, so I know all the sides and angles are the same length. There are 1, 2, 3, 4, 5, so it's a pentagon. And all my sides are 8, so the perimeter is 8 5 times. So my perimeter is 40. My slant height they gave me is 12. So 1/2 of 40 times 12 is 240. My lateral area is 240 feet squared. Let's look at 4B. Find the volume of the composite figure. So this one is a little different than the last one because it's a little bit different shape. I still have a cone on the bottom, but I have a half of a sphere or a hemisphere on top. So on this one, I'm going to need the volume of the hemisphere. And then to that, I'm going to add the volume of the cylinder. And I'm going to add those two things together once I get them. Okay, so I'm going to do them as 2 separate little pieces. Now my hemisphere, that's not on my formula chart. I have the whole sphere. The volume is 4/3 pi r cubed. So if I just want half of that instead of 4/3, we're just going to do 2/3. 2/3 pi r cubed for my hemisphere. 2/3 pi r cubed. So 2/3 pi my radius cubed. My radius is going to be halfway of all the way across, so it's going to be 5. So 2/3 times 5 to the 3rd power. Remember the little up arrow here lets you raise something to the 3rd power. Gives me a decimal. If I change that into a fraction, I get 16/3 pi. That's the volume of the hemisphere. My cylinder is pi r squared h. So that's going to be pi times, we have the same radius, 5 squared. My h, my height is 6. Okay, so 5 squared times h times 6 is 150 pi. So to find my total volume, I'm going to add these two together. My 16/3 plus my 150 pi. Notice I didn't put my pi in the calculator. When I hit enter, I get 155.3 repeating. Let's see if I can make that into a fraction. So my total volume is 466 divided by 3 pi, which is about, let's see, times pi, 487.994 meters cubed. There is my volume of the composite figure. Let's look at 5b. The volume of a cone is 42 centimeters cubed and the height is 10 centimeters. What is the diameter? So it's the same as the last problem, only we are given different numbers. Instead of 64, we have 42. Instead of 4, we have 10. So my formula, I'm going to use the same information. My volume equals 1/3 pi r squared h. My volume is 42 equals 1/3 pi r squared. My h is 10. And let's see what I did. The first thing I did here is I multiplied both sides by 3. When I do that, 42 times 3 is 126. So I've got 126 equals my 1/3 and my 3 canceled out. So it's just pi r squared times 10. Then I divided both sides by the 4 on the end here. So I'm going to do that. I'm going to divide both sides by the 10. So 126 divided by 10 is 12.6 equals pi r squared. Then I divided by pi over here, which gave me 12.6 divided by pi equaling r squared. But again, we didn't want r squared, we wanted just r, so I'm going to square root both sides. I'm just following the exact same process we did over here. The square root of 12.6 divided by pi, and when I look, I make sure the square root has gone all the way across, even the pi. And when I hit enter, I get 2.003, or we'll round that to 2 as my radius. But I don't want the radius, it says to find the diameter, so my diameter here is 4. And these are centimeters, 4 centimeters. Okay, let's look at 6b. Find the volume of the pyramid. So my volume of my pyramid is 1/3 the area of the base times the height of the pyramid. So that's 1/3 the area of the base times the height. My base is a triangle. It's not a right triangle this time. I can see I've got 6 along the bottom here of this triangle. And then they gave me the height as 5.2. So that was helpful because I can find the area of my base that way. Because the area of a triangle is 1/2 its base times its height. So that's going to be 1/2 its base, 6, times its height, 5.2. So 1/2 times 6 times 5.2 is 15.6. That's the area of the base. The height is the different from the height here. Notice height here was 5.2, but this height in my volume formula is the height of the pyramid, okay? Now on this one, my height of my pyramid is going to be straight down and then out. Now, if I'm 5.2 all the way along here, then half of 5.2 is 2.75. So 2.75 all the way across here. Okay, so if that's 2.75 and that's 8.2, that's really a slant height there, because see how it goes to the edge? So that's really a slant height. So I have to figure out what my height is. My height is going to be a leg. So I'm going to take 8.2 squared and I'm going to subtract the 2.75 squared. 8.2 squared minus 2.75 squared gives me 59. Oops, I forgot to square root that. I was like, why is that so big? Let's square root that answer. The height of this pyramid is 7.725. Okay, so my volume equals 1/3. Oh, I don't need to rewrite that. I can just put that in the calculator. 1/3 times my 15.6. And if you want as little rounding as possible, you can take that previous answer and put it in there. Close your parentheses. And when I hit enter, I get a volume of 40.171 units cubed. So I did have to find my height on that one, and I just used Pythagorean theorem. Okay, let's look at 7b. The lateral area of a cube is 16 square feet. Find the volume of the cube. So this is going to be the exact same process as the last one, where I'm using the same cube, right? The same cube, which means my perimeter of my base. I'm going to go ahead and make myself a border here. But my perimeter of the base is still going to be 4x, and my base is still going to be x squared, because it's still a cube and I still don't know any of the side lengths, right? So for my base, it's still a square, and I don't know any of those lengths, so it's still x and x and x and x, which means my perimeter is still 4x, and the area of my base is x times x, or x squared. Okay? So then, when it tells me that the lateral area, which I know is the perimeter times the height, is 16, my perimeter is 4x. The height of the prism is x. So 16 equals 4x squared. Divide both sides by 16. Divide both sides by 4. 16 divided by 4 is 4. That equals x squared. So then to figure out what x is, if I square root, x has to be 2. X can't be -2. It has to be a +2 because it's a side length. So that means my perimeter is 4 times 2. My perimeter is 8. My base is 2 times 2. My area of my base is 4. Okay, so then when I come over to find the volume, which is the area of the base times the height, my volume equals the area of the base was x squared, but x was 2, so 2 times 2. And the height of the cube is x, and x is 2. So the volume is 4 times 2. My volume is 8 feet cubed. Okay, let's look at 8b. Winnie asked Molly to pick a card from a standard deck, then replace it 3 times. Each time Molly pulled an ace. What is the theoretical probability that she will pull an ace a 4th time she pulls the card? Okay, now notice that each time she puts the card back, okay, she replaces it, which means there's no effect on the next card that she pulls. So when I find the probability that the next time she's going to pull an ace, what's the probability that this next time she pulls an ace? There are, well, let's see, how many aces in the deck? 1, 2, 3, 4 aces out of 52 cards. Oops, let me rewrite this a little bit more standardly. I'm looking for the probability that we draw an ace. There are 4 aces out of 52 total cards. 4 divided by 52, math, make it a fraction, is 1/13. Then we are going to change that to a percentage. So math, make it a decimal, multiply it by 100, and I get 7.69. So we'll just say 7.7%. 1 out of 13 tries, or 7.7%. Okay? 9B, Mr. Fagarasi is holding a bag with 1 red marble, 1 blue marble, and 1 green marble. He asks 3 students to each pick a marble and keep it. Whoever picks the green marble will go first. Maggie picks first and gets the blue marble. What is the probability that Daisy will get the green marble if she picks next? Okay, so we are looking at the probability that first Maggie got a blue marble. Then Daisy gets green. So the probability that Maggie gets a blue marble is there is 1 blue marble out of 1 red, 1 blue, 1 green. There are 3 marbles total. Then Maggie's going to keep it, right? It says 3 students each pick a marble and keep it, right? So it's important to know they're going to keep them. So now Daisy's going to pick, and she wants a green marble. There is 1 green marble, but now there's only 2 marbles left in the bag. So my probability is 1 times 1, and then 3 times 2. So 1/6, or times 100, 16.7%. Okay, let's look at 10. Find the probability that if a bird lands in the field, it will land where there is wheat growing. So this time I'm going to find the probability that the bird lands where there is wheat. So for the wheat area, landing here, the area of the wheat is going to be 175 by 500. So that is 8,000 or 87,500. Over the total field, which my dimensions are the same in each of these problems, so I can use my area from the last problem, 360,000. So 87,500 divided by 360,000, math, fraction, enter, is 35 over 144. As a percentage, math decimal times 100 is 24.3%. So not as likely that the bird is randomly going to land in wheat as it's going to land in corn. And if that makes sense, right? Corn is a much bigger area than wheat. Okay? All right, let's look at these last 3 problems. Leah is spinning the spinner below twice. Find each probability. The probability that we land on 5, and then something less than 4. So how many 5s are there to choose from? On my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 0. There's 1 5. Out of how many? So it kind of looks like there's 10 wedges, but because there's 0 here, there's really 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's really 11 wedges or sectors to this spinner. So 1 5 out of 11 spaces times less than 4, that would be 0, 1, 2, and 3. So there's 1, 2, 3, 4 spaces that are less than 4 out of 11 spaces. So 1 times 4 is 4. 11 times 11 is 121. 4 divided by 121, math fraction enter, does not reduce. Math decimal enter times 100 is 3.3%. 3.3% is the probability of landing first on 5 and then on some number less than 4. Okay. The next one, the probability of landing even and then landing odd. So landing even. Now remember, 0 is neither even nor odd, right? 0 is considered neutral. So my even numbers are going to be 2, 4, 6, 8, and 10. So that's 1, 2, 3, 4, 5 spaces that are even out of 11 spaces. And odd numbers. So that's going to be 1, 3, 5, 7, and 9. So 1, 2, 3, 4, 5 spaces are odd, which makes sense because that's 10 of my spaces, and the 11th space is neither even nor odd. It's neutral. 5 times 5 is 25 over 121. 25 divided by 121 as a reduced fraction is 25 over 121. As a decimal, times 100 is 20.7%. Okay, let's look at the probability of landing on 0 and then landing on 8. So 0, there is 1 0 on that whole board. So 1 out of 11 times 8. There is 1 8 on this whole board. So again, 1 out of 11. We're going to multiply these together. 1 times 1 is still 1. 11 times 11 is 121. That's not going to reduce. 1 divided by 121 times 100 is less than a percent. It is 0.8%. Chance of landing on first 0 followed by 8. Okay. If you have any questions about anything on any of the problems that we went through in any part A, part B, part C of the final exam reviews, make sure you are attending sync time if you're not an in-person learner and asking. If you're an in-person learner, make sure you are using that time wisely and asking questions for anything you still have questions about. All right. Thank you so much for watching.